everybody, and welcome to part 13 of my C++ programming tutorials. Today we were going to be covering arrays, but we're not. We're covering random numbers, and there's a very simple reason for this. Is I was going to teach arrays, and I actually started to record the video, and then I realized how much time it would take to actually fill the arrays with stuff by hand. So random numbers kind of helps with the tutorial a little bit, but I need to teach you guys that before we actually use it. So I'm going to erase everything here. Let's go ahead and just let's get rid of everything. And we're going to test out random numbers. Now, random numbers are a really complicated topic with C++, because computers don't know how to do anything randomly. They only know how to do what you tell them to do. So we can't just say, hey, make a random number, and it make a random number. It doesn't know how to do that. So we need to call a function random, and that's going to include a C file. It's going to be include rand. What is it? It's in the stdlib file. So that's it's a C file, so it needs a .h at the end, and it's just a standard library file, and we need that to use these functions. Now, the way random numbers work in computers is it's a very complicated mathematical algorithm that takes a seed number and it does a bunch of math on it to try and produce a random number. So first, to actually produce a random number, we need to give it a seed value. So this is a seed random, this function here. And what this does is it takes an integer variable, and it needs to be an unsigned integer variable. So we can give it, say, 5. Let's give it 55, okay? And that creates a seed for our random function. Well, I'm going to want an integer here. I'm going to want an integer here. And this is going to be int number. And we're going to set number equal to, you know what, let's do a for loop here, because we haven't really showed those yet. So let's do for I int I equals 0, and then we'll say as long as I is less than, let's say 50, let's do something small, 10, then we'll increment I by 1. Okay? So in this random, we'll call number equals random. It's just rand, and then that's it. It's simple as that. Now what this is going to do is it's going to give us a result of a random number between a very large value. So it'll just give us a random number. Well, the way to actually tell what random number we want is to take the modulus of that random, what rand results. So remember, modulus is a remainder of this value. And it's kind of hard to explain why it works, but it does. So we'll take modulus 15, and what that's going to do is it's going to give us a random number between 0 and 15. Okay? And if we wanted to do 1 through 15, we would just do 14 plus 1. And that would give us, it would add 1 to the end, or to the beginning of the random number sequence, and 1 to the end. So that would give us a result of 1 to 15. So let's go ahead and just do that. Well, now I want to see out, and I want to print the random number to the screen. So we'll say cout number, and then we'll do end L. Good. So this will produce a random number sequence. It's going to produce a sequence of random numbers. So we got 9, 14, 8, 10, 5, 10, 3, 6, 6, 3, right? And that's kind of pseudo-random. Now, one of the things that we need to look at here is that if we remember to say the first three, 9, 14, and 8, let's run this program again. And look, it's the same exact results, and that's because it's using the same seed. A good example of this would be in gaming. Let's say like Minecraft, because it's a really popular one. In its map generation code, it uses a random algorithm to produce randomized maps, and they're pseudo-random. And they don't use like the rand function. They use a what's called a Perlin noise generator, and that's a whole nother tutorial series, so we're not going to get into that, but it's very similar. It takes a seed number or seed string of words or whatever you want as a string, and it outputs random information. Now, say that you wanted to save the map, give the map to a friend to start out in the same spot. Well, that seed can be used to produce the exact same map. And that's exactly what's happening here, is it's producing the exact same set of results. So how do we give a more random, how do we try and make it a little bit more random for the user of this program? Well, we're going to use a function called time, and we're going to set time 0. And what this is going to do is it's going to take the system clock time in seconds, so it'll be hours, minutes, seconds, and seed it with that number. Now we need to include another C file, and this is going to be time.h. Simple enough, right? So we include time.h into our program. C time. Why isn't the include function working? Include time.h. I don't know why that didn't work. Not time API. Just need time.h. Okay, and that'll let us use the time function. Now what this is going to do is it's going to seed time, and don't forget the second set of parentheses like I did. It's going to seed the random number with the system clock. So if I hit F5, we get 197. If I close that and hit F5 again, we get 1418, and it'll continue to produce random results for us. Now, if I were to seed say if I were to copy this real quick and just paste it here, well, what we would expect is 2 separate random results, correct? But we don't. If we look after the 15th number, we start to see a repetition. So 3, 14, 13, 3, 14, 13, 2, 2. And the reason for that is it actually seeded the random number with the same system time, because not more than a second had passed. So it seeded with the same time. That's pretty much it with random numbers. I could go on for a really long time with these. The one thing that I do want to mention is that the way that we produce random numbers here using the modulus, there's one small problem with it, and you won't notice it until you get into like generating like thousands of different, like hundreds of thousands of different numbers. It actually leans towards the lower numbers. I'm not exactly sure why. It's just the function, like the algorithm used. It's more likely to produce a lower number than it is to produce a larger number. And there's not much you can do about that. Most of the time you will not notice it unless you are producing huge results, and you can go ahead and try that for yourself by trying to produce like tons of numbers and maybe do an if statement if the number is less than 100, then increment something and then print out that increment at the end, and it'll tell you how many numbers you got that were less than 100. So that's it for the random numbers part of this tutorial. Next episode we will be covering arrays, and that's going to be super fun because they're very complicated bits. So thanks for watching, guys, and I'll see you next time.